Welcome everyone to today's Glass Academy webinar. We're thrilled to have you join us for this insightful session on framing the future, trends in glazing systems and safety. In the asset industry, glazing systems are essential to modern construction, blending innovation with safety and sustainability. As we create iconic architecture marvels today, it's vital to understand these glazing systems that shape our city skylines and interiors. From energy efficient facades to enhanced safety measures, staying updated on advancements in glazing systems is crucial for building the future responsibly. Today, we are honored to have with us Mr. Eshan Hemrajani, Director at Glasswall Systems India Private Limited, India's leading facade fabricator. Founded with a vision to turn architectural dreams into reality, Glasswall Systems provide turnkey architectural facade solutions that deliver on both innovation and quality. With cutting-edge design, manufacturing, and product management facilities, they have set the benchmark in the industry. Headquartered in Mumbai, Glasswall Systems has a strong presence across India, including Bangalore, Delhi NCR, Kolkata, Ahmedabad, Hyderabad, and Pune, establishing itself as a true pan-India company. Their expertise extends globally to the US, Australia, Qatar, and Sri Lanka, offering a complete range of glazing systems and custom design architectural metalwork. Mr. Eshan joined Glasswall Systems in 2014 and brings a wealth of experience across operations, human resource, marketing, and overall factory operations. His academic backgrounds include an MSc in Engineering Business Management from Warwick University, UK, and a BE Civil degree from Cardiff University in UK as well. With Glasswall Systems, Mr. Eshan aims to leverage his invaluable experience on the operations side of business to produce products as per the required international standards within the demanding delivery timelines. He's also focused on sustainability and is leading the narrative on green low embodied carbon products in the country. So welcome, Mr. Eshan. We are thrilled to have you here with us today. So without further ado, I'll now pass it over to you to begin your presentation. You may now share the screen. Over to you.
So thank you, Anvita, for having me here today to speak on Glass Academy. It's always a pleasure to do this. I think today's topic, I'll just share my screen first and then we can jump right into it.
Sure.
So I think today's topic of discussion for me is going to be a fairly simple topic. It's on the basic understanding of certain curtain wall facade systems. This is what I'm going to be presenting. So we can get a hold of the basic systems used in our industry. And I aim to keep this simple, and obviously we can then take it forward from there. So what I'm going to start with is a quick introduction about the company that I'm representing, Glasswall Systems India Private Limited. We are in basically facade fabricators based out of Mumbai, India. And what we do in the country is we execute turnkey jobs related to facade on buildings. And we do everything in terms of a design and build. So we have our own engineering team, we do our own manufacturing, and we do our own installation on site as well. So we do an end-to-end service for our clients across India and now even in the US and Australia. We are a fully vertically integrated company. When I mean vertically integrated, I think everything with regards to manufacture of the product of facade is done in-house. And those services are available with us under different brand names under the same umbrella group. So we have our own powder coating and PVDF coating units, which is basically to coat on metal. We do our own wood finish coating as well. We also have our own sheet metal unit where we do all sorts of sheet metal works, where we handle stainless steel, mild steel, galvanized iron sort of products, 0.8 mm right up to 16 mm. So this is also a capacity in-house where we are doing all facade related products as well as other products like fire rated doors, fire rated partitions, and paint vestibules and stuff like that. The flagship company where we are carrying out facade works is Glasswall Systems, and I look at the operations in this company. We are present globally, but our head office is based in Mumbai, India. All right. So Jumping right into it, I think facade is basically meant to be anything on the exterior of the building, and it is derived from the French language, which is frontage or face. Facade as a concept has evolved tremendously over the past many years, and it is basically, in my understanding, a function, a balance between function and aesthetic, and the right and people are striving to get the right balance between both. Uh, they sometimes work in tandem, they sometimes do not. So, what we aspire as engineers or builders, we cater to both sides of the subject, where we cater to the aesthetic determined by the architects and also the function determined or required by the clients or the consultants on the job. What you have as a result is very pretty looking buildings, and this is what we aim to do. There are some key factors when you design a facade system on a building. Um, Obviously, the first and the most important thing is that you have to choose the right materials and finishes, because being on the exterior of the building, uh, it is under a lot of pressure or under a lot of duress in terms of air, water, seismic movements, and stuff like that. So basically, the facade system on the exterior of the building and the materials that go into making that facade have to be able to withstand all the forces of nature, all the key elements, environment elements. So this is one of the most important things, that you have to find a balance between in terms of the aesthetic and the function of the material that you're choosing. Any sort of facade system on the exterior has to have uh, strong principles in terms of drainage and water management, because the function of the facade is to um, not allow any sort of nature or natural element in terms of water as well to kind of enter the building and have problems like mold or leakage or other issues, right? So any system has to have adequate drainage designed into it. It has to be properly insulated. Thermal performance is of high importance, because you want your facade to have maximum vision typically on a glass building, but you want minimum heat loss from the building. So what you need to cater in terms of the design and the elements that you use is to obtain a high thermal performance on the building. What we have right now, and which is gaining trend with the vision of the world and vision of India also, is to use sustainable and eco-friendly elements. We all have I believe, a larger aim in our lives to um, take as little as we can from the environment, and we need to start exploring as an industry more and more sustainable and eco-friendly elements to use on the facade. Wind loads and structural integrity obviously are of utmost importance. It's structural safety in terms of the facade and the integrity of it, because the building is expected to stand for minimum 30 years without maintenance, 25, 30 years, even longer. Sometimes you design structures for 100 years. So the math that goes into it, and again, it's a function between having the right cost on the job as well as having the right integrity of the system in terms of structural performance. And that is something that needs to be taken into consideration when designing any sort of facade. Typically, my facades are marketed to be maintenance free or have minimum maintenance. However, you need to be sure as to how you're going to maintain the facade from the exterior of the building. So you need to incorporate any sort of accessibility and maintenance features while you're designing the facade itself. There are several types of facade systems, and each of them have their own advantages, disadvantages, strengths, and weaknesses. Typically, what I want to talk about today is curtain wall systems, which are basically aluminum and glass, and different systems in the curtain wall systems of as an infill of glass. We have rain screen facades as another type of facade systems. It's nothing but a rain screen, as the name calls it. So you have an exterior cladding which is attached to the building structure, but it allows for ventilation and drainage as a pressure equalized system, uh, acting as an aesthetic element more to do. Whereas curtain wall systems have to be not only an aesthetic element in terms of cladding material, it has also a huge amount of performance that it has to adhere to, performance spec that it has to adhere to. So what you have right now is a picture of a rain screen cladding, which allows circulation of water and air, in effect becoming a pressure equalized system. So typically rain screen claddings is acting as a second skin. So you have a primary skin, which is typically a brick wall or some other material, insulation material. And then you have the rain screen cladding as a second layer acting on it, providing the aesthetic to the building. We also have sandwich panels. These are pre-insulated panel systems. These can also be used in lieu of curtain wall systems wherever maybe glass is not desired on a exterior element, and insulation as a criteria is high in the requirement of the application. We have some sandwich panel systems that are now also gaining much popularity. So as I said, we're going to speak a bit more about the curtain wall system. Um, there are typically two types of curtain wall system. One is the conventional system, which is a cap system, where there is no structural glazing in terms of the silicon used to bond the glass onto the frame. And the other one is with the structural silicon. And it has two sub criterias or subsystems. One is the semi-unitized system, and the other one is the unitized system. So we will touch upon all these systems today briefly. So first we'll talk about the conventional system, which is what we call as a stick curtain wall system. These are basically the aluminum profiles or the aluminum components are installed directly onto site, and the glass is held mechanically with a cover cap and a pressure plate. So what you have with these kind of systems, which were done initially a while back, was this was done typically on site. So you did not have the need to have a factory, and this was all fabricated on site. So that was how it used to be done earlier. But there are some disadvantages to this because everything is now carried on site. So there is a longer installation time attributed to doing stick curtain wall. Obviously, there's a certain less importance given to quality because everything is now executed at the site itself as opposed to a control environment in a fabrication shop. So there is definitely a potential for more errors in terms of the fabrication and the finished quality of the product. Also, it is heavy on labor because everything is to be executed on site. So there is a increased labor cost, increased safety concerns to execute this kind of a system now on site. So this is how typically it's done, where you have the aluminum components and then you have the glass, which is a mechanical fix with a pressure plate and a cover cap. So the grid work goes onto the site. It goes onto the site, and then the glass is kind of manually placed into position with the help of hoists and then fixed up mechanically. Typically, stick curtain wall is not pressure equalized, which is one of the most important functions of a exterior facade. But nowadays, you do have certain stick curtain wall systems which are also pressure equalized. So these are some of the snapshots where you can see that the grid work is already installed on site and the glass is being hoisted into place via crane and fit out manually. For larger buildings, in terms of height, the skyscrapers that you see nowadays, this system becomes tedious to do because then you cannot access at a certain level to do this. So there is a definite height restriction to execute these kind of systems, and they are more or less now used for renovations or smaller heighted buildings, or wherever there is some sort of complexity involved in the structure which requires site survey to be done and a structure to be built on site. That's typically when we go for such systems now. These are some more examples of a stick curtain wall being executed on site with a pressure plate and a cover cap. These are all glass wall projects. Then what you had as a natural evolvement on the systems was a semi-unitized system. This is basically a cross between the conventional stick curtain wall and a unitized system. So what you have is the grid work coming onto the site as aluminum grid work, similar to what happens in the stick curtain wall. But the glass with a sash frame with an aluminum subframe or an aluminum members around it is glazed in factory and then fixed on site. So it is not completely a site executed work, but it is a midway point between a unitized and a stick curtain wall system. So as you can see here, the building structure with the aluminum framework and then the sash, as we call it, with the glass, which is glazed in the factory, comes in and fits into the cavity or the grid work. What you have now, typically used around the world, is a unitized system. This is where everything is done into the factory, as in the whole panel as a unit, along with the aluminum members and the glass structurally glazed into the unit, comes as a finished product from factory and is ready to install on site. This is something which is now considered to be the norm in the industry as a standard system to be used across projects. What you have with unitized systems is, because it is first of all completely made through factory, so there is minimum value add on the site itself. That improves control on material quality, incoming material times, obviously in terms of the accuracy of the product is very high because everything is done in a controlled environment. What it also does is it reduces hugely the requirement of labor on site, because now you don't need to have access equipment to start with in terms of scaffolding or anything else to install. What you just need is a simple hoist and a crew of 7-8 people to install maybe 50-60 panels on site. So what you have is faster installation time on site, definitely, and reduce waste and labor cost. What you also have is, because then you can test the entire product for water tightness and thermal performance, you get better performance also with this system. So there you can see now there is no particular aluminum grid work which is installed on the site. The whole panel as a unit is coming in along with the spandrel and the vision glass and is fitting into each other like a puzzle, like a jigsaw puzzle. So you have a male and a female joint between either panel, which acts as the air and water barrier, and kind of goes one after the other onto the site. Sequencing is important because you have to follow a certain sequencing in terms of installation. But definitely, this is one of the most evolved systems as of now available in the industry. So this is basically a section view of typically how a unitized panel looks, where you have the vision panel, which actually provides the vision as the name calls for it. Then you have the spandrel section, which is typically in between floors. The spandrel section definitely has its own performance criteria to maintain. Basically, there are two things in the spandrel panel. One is to ensure that the whole assembly from the floor and the spandrel panel together acts as a smoke barrier between the two floors. That is one of the most important functions of the spandrel area. Insulation at the spandrel area prevents heat loss. So thermal criteria is the second thing for the spandrel area to cater to. And the third is obviously because you have a solid kind of a shadow box or a spandrel behind the vision glass. It provides an aesthetic uh, fulfillment of performance as well, so that anyone standing on the exterior of the building is not able to see the slab at the back. So all your services in terms of, let's say, your the slab area, the false ceiling, and all your services can run behind the spandrel area. So to have a well-designed spandrel as well as a vision is the basis of a unitized system. One of the most important things is, as we mentioned earlier, is any system has to have certain performance criteria in terms of the structural, in terms of the water penetration, in terms of the air penetration, in terms of the thermal performance. So this is a typical sketch of uh, what a unitized system looks like, where you have the rain screen gasket at the front, um, and then you have the water and the air barrier right at the back, and then you have the splice joint between the two panels. So you can also see a setting block, which is required to take the dead load of the glass. And then you have the spandrel glass at the bottom. You also see the insulation of the back pan, which is a part of the spandrel panel. Typically, the insulation material that we use is rock wool, or rock wool is the company name. The technical name is mineral wool. Again, what you see here is a typical vision panel plan, where you have the male and the female profile, which come into engagement with each other. And you can see in front the glass, which is the IGU, insulated glazing unit, structurally glazed. You have the lips as an extension of the profile. This can be used as polyamide or for enhanced thermal performance as well, or you can use aluminum lips. What you have in the front is the main rain screen gasket, and then you have multiple what we call as water barriers in terms of gasket engagements behind the main rain screen gasket. You have the wet chamber, as we call it, as well as the dry chamber at the back. This is a typical section of the stack joint where you see the sill and the gutter engagement. Again, the rain screen gasket on the front, and then you have the airline right at the back of the panel. And you can also see the bracket with the hook-on plate in terms of having to fit the panel in place and also to cater to movements and let's say civil undulations or civil tolerances or manufacturing tolerances on site. The bracketing or the structure which is used to hold the unitized panel is designed in such a way that it can allow for site adjustments in a vertical as well as an horizontal axis. Here you see some more examples of different shapes that can be achieved with aluminum used as a profile, which is extremely malleable, and with the right alloy gives you the right balance of strength, as well as having a huge opportunity to make different shapes. So maybe if I want to talk a little bit more about it, the typical alloys we use is 6063, 6061 with various tempers, T4, T6, T5 tempers used of aluminum. And as I told you, it is a non-corrosive material or highly or good non-corrosive properties. It has a good thermal um, property as well, and it is extremely malleable. So aluminum, and it is lightweight, and it gives you the right structural properties. So as a composite, this material is widely used in our industry as a framing material along with the glass. Yeah, so I think this is just a small snapshot of how it eventually terminates at the top of the building, where the glazing line, which is beyond the building line as a continuous glazing in terms of a unitized glazing, gets terminated with a proper flashing and a membrane on top of the building to prevent the water coming in behind the system. So as I mentioned earlier, every system has to have a performance, and these are designed to perform to a certain air infiltration, to a certain water penetration, as well as a certain structural criteria or structural load test. So what you basically want is the system to not have water inside it. You need to have higher level of vision. So a good thermal performance is also required, and then structural stability. So what you have is typically third-party test labs where you build out the whole or a part of the project, and then you test it to the project criteria in terms of wind, in terms of air, and in terms of water. And what you get to learn from that is whether the system will perform under worse conditions on site, and you have minimum failures on site, because that is not something that you want to deal with on the project level. So I want to discuss a bit about what sort of criteria goes into designing a facade system. One of the most important things, as I mentioned, is thermal properties, and it depends on where you're designing the system for. Because let's say in India, um, the delta T, or the temperature difference between the ambient temperature within the building and the temperature outside, there's not too much of a difference, because typically you're looking at 25 or 26 degrees Celsius within the building, and at max in a country like in a city like Mumbai, you're looking at 40 degrees on the outside. So you're talking a delta T of 15 degrees. So what you typically want is minimum energy loss in terms of air conditioning from within the building to outside. So how do you achieve this kind of a thing is what is important. If you go to a European country, or say the United States of America, where the temperature on the inside would still probably be at 25 degrees Celsius, but the outside temperature is at minus 10 or at zero. So here you're dealing with 35 to 40 degrees of delta T. So what essentially this means is your system has to cater to this kind of temperature difference, or what you could lead to is a high level of energy loss. Uh, when you design for such colder environments, what you want is minimum cold to come in, and the heating cost to be maintained inside the building. So typically we are dealing with two components, that is the glass and the frame. So in India, let's talk about the frame. We don't use thermally broken systems because the delta T is not too much. But anywhere outside India, we use something called as a thermally broken or a thermally enhanced system. What that basically means, because aluminum is good conductor of heat, you need to break the good conduction, because there is exposure of aluminum to the inside of the building, as well as certain amount of exposure to the outside of the building. So what that is done with is to incorporate polyamide, or a sort of a plastic, in between the system to break the profile into two sections, so to say, to avoid the heat loss from the frame itself on the inside and the outside. Then the main surface area of the facade is the glass. So typically you do IGUs, which is two panes of glass with an air gap in between, and a spacer tape with desiccants on the side. So the IGU as a unit has to have a certain performance criteria that has to be catered for the spec of the project, along with the facade system. So what you have now in glass is you have performance coatings available, which give you a certain solar heat gain coefficient, or a condensation resistance factor, or a thermal resistance. And all of these are basically essentially criteria on the glass in terms of their performance. You want maximum light to come in, but minimum heat to come in. So you could have a highly reflective glass, uh, reflecting all of the light outside. But what that would give you is a mirror from an outside perspective looking into the building. And you don't want a mirror, right? You want something which looks fairly neutral. So how do you achieve, without having a high reflectance, a neutral look to the building, as well as ensuring performance? So then you have performance coatings available on glass today, with a single silver, a double silver, as well as a triple silver um, performance criteria on the glass, which gives you these performance points to achieve a higher clarity, a higher visual light transmittance, as well as a lower solar loss on the glass. So along with the frame, and a right glass with the air gap, which again improves performance. You have to balance the both to get the right thermal performance on the system. There are different ways to do it. There are different softwares available to see where the maximum heat loss from the system is going to be. And this analysis is done at the beginning of the project in order to see that the spec of the materials that are being used are meeting this performance criteria. Obviously, in a city like Mumbai, you have huge traffic and noise on the outside, noise pollution on the outside, and it's similar for all places in India. But when you are in your office building or your residence, you want minimal amount of acoustic loss, or you don't want noise to come into the building. So the system has to be designed for acoustic comfort as well. Again, so there are two major materials again that need to take care of that. The IGU or the glass unit along with the air gap definitely acts as a barrier for sound transmission. And then your system itself with the proper sealing in terms of the gaskets or the joints that are being designed reduce the amount of sound coming into the building. So this has to be definitely designed. The system has to account for that kind of criteria. And we discussed earlier about insulating materials as well. And what that insulating materials do is not only improve thermal performance, but it also improves the acoustic performance of the whole system. There are acoustic interlayers available even in the glass today, which not only add to the structural strength of the glass itself as an interlayer, but it also adds to the acoustic performance of the glass. So if you get the glass correct and the frame correct, you can achieve both criteria. There are different interlayers available in the market. The basic interlayer is what we call as PVB interlayer, polyvinyl butyl, which has certain structural criteria performance as well as acoustic performance. And then it goes all the way up to something which is called as a sentry glass, which is a high performance interlayer with higher structural strength, typically used on glazing application, on railing applications, skylight applications, which are open to, let's say, human abuse or other abuse. It has a higher acoustic performance as well as a higher safety performance. So there are various interlayers available in the market that can be chosen to get or cater to the right project spec. Pressure equalization is most important, basically because we are designing the two panels as individual components and they are not mechanically fixed to each other. What this allows the system as a composite to have movement in terms of seismic on two directions, not inward and outward from the building line, but definitely on a horizontal and a vertical position. The system has to be able to breathe and cater to these sort of movements. So when you have a pressure equalized system, what that means is you don't have condensation within the system, or even if there is some condensation, it has to allow for that water to go out. And which the most important element in allowing this movement without structural damage, in allowing pressure equalization, in allowing a good air seal, are the gaskets that are designed within the system to allow this sort of pressure, this sort of compression on it, as well as a movement to achieve a proper pressure equalization, as well as a structural movement on the system. So what you have typically, what you can see is a pressure equalized chamber and a rain screen chamber. Ideally, you don't want the water to come into the system itself, but if it does, in the wet cavity, as we call it, the one that you can see on the yellow, it needs to go down into the, as we call it, the stack joint on the gutter, and there has to be provision for drainage to let the water come out. And then behind that, with the multiple air seals or the water barrier, you have the pressure equalized chamber. And towards the end that you can see is the last air seal gasket at the back of the system. So typically, if your air is leaking into the system from the outside to the inside, it is understood that you will not only have energy loss, but you will also have water eventually coming into the system. So the air seal gasket, which is the last sort of defense or the last line is very important to maintain on site as well as in factory as well as in design to ensure that your system is performing and there is minimum air infiltration and same with water. As I've discussed just now, the air seal at the back also acts as the last line for a water drainage. If you cross the air seal, eventually you will have water coming into the building. So with multiple barriers designed into the system, we try to minimize or practically make it to zero the chance of air and water ingress into the system. We have discussed this earlier. There are softwares available to study, let's say, the wind acting on the building. And there are ways to do it. There are specific agencies to carry out wind tunnel tests, which map out the entire city, so to say, and then simulate in a software the kind of wind loads acting on different parts of the building, which is then put into a project spec and then designed for. So before you get into the design of the system, there is definitely at the initial stage of the project a wind tunnel test that is carried out to determine the huge pressure zones on the building, and then those localized pressure zones are then maybe enhanced in terms of structural integrity or what they are supposed to cater to, and are taken care at the design stage itself. The typical way that the load is transferred onto the structure is fairly simple because these are all dead loaded onto the, let's say, the verticals and then back onto the bracket onto the slabs. So the slab design that is done has to cater for the loads of the facade that is hanging from it or is attached to it. So what you have is the primary load or the wind pressure in terms of an active load acting on it, and which is going then onto the structural members in terms of your verticals or the mullions going onto the um, slab or the superstructure. So these have to be designed to cater to these kind of loads. As I mentioned earlier, also one of the most important things is to cater to movement of the facade. If you have something rigid, typically in terms of stress, it will break. So you don't have a rigid joint, as I mentioned earlier. So there is a certain amount of movement allowance in terms of upward and sideways movement on all the unitized curtain walls that are designed to allow in case of a seismic or an earthquake to not break and fall off. So this is, as you can see, some snapshots where you can understand that there are slots provided even on the hook-on bracket as well as the floor bracket to allow this sort of movement. Obviously, there are limitations to this, and beyond a certain point, if there is movement, you will get a full, let's say, a disintegration of the system where it is a complete failure. There you can see sort of movement testing happening on the performance mockup. Here you can see the stack joint in a closed position and how it can go up to a maximum level in terms of a vertical movement. So this is important to study before we actually design the systems so that there is no disengagement and a total failure of the system. Fire safety is one of the most important. We spoke earlier about it in terms of having what you call as a facade which is safe in terms of a fire that happens. Here we are discussing predominantly about unitized panels. So let's discuss a bit on how glass is. Glass will break at 500 degrees Celsius. And when you have a fire, you're looking at anywhere between 700 to 900 degrees Celsius. So the glass, in case there is a fire on a slab, will break immediately. So what you need to do is first you need to fight the fire with passive firefighting systems within the building itself in terms of your fire retardants or your sprinkler systems or whatsoever other ways are there to fight the fire, and you need to stop the propagation of fire from one floor to the other. So typically the facade system has to cater to avoid propagation from one floor to the other. And that's where the smoke seal or the spandrel system as a whole assembly comes into play and is of big importance. So here you can see clearly that the slab, along with the mineral wool insulation as a smoke seal and the spandrel panel together form a composite assembly that even if there is fire on a below floor, it will not propagate within the building because hot air rises, smoke rises, and what kills literally is the smoke. So you want the smoke to prevent, you want the fire to not go upwards. So this is, as a fire rated assembly, is one of the most important things to cater to in terms of a building design. So what you see here is what we call as a leapfrogging effect, where if there's fire on a below floor, it will definitely break the glass and go on to the above floor. But what you need is to see that the fire propagation remains up until the spandrel panel and does not go on to the vision above. And also you don't have, or you have zero propagation within from within the floor to the other floor. So these are just some examples of how fire safety has to be taken into consideration while doing this. We also have operable vents, as we call it. Um, this is just basically in definitely in terms of residential buildings to allow to come in, because we all love our air to come into our residential building. But in commercial buildings, which are typically in air condition all the time, we do have the fire department mandates a certain amount of openings to be designed on every building, so that in case there is a fire, smoke, which is the big killer, the operables are allow the smoke to escape by opening it. And a lot of the new buildings now are linking to the building maintenance, or the fire system is linked to the operables as an auto operable. So whenever you have a fire, not only do you have passive fire fighting immediately, you also have the vents that open out automatically to allow the smoke to escape and minimize loss of human life. Obviously, we spoke about a lot of things that you need to do correctly for a facade system to perform. And obviously, if you miss any of those, you would definitely have failures in your system. So to choose the right performance criteria on the project, to choose the right materials, to choose the right system, to choose the right fabricator or your partner to install it is all of extreme importance. One needs to take or weigh into consideration the strength of the fabricator, the quality requirements on the job, the schedule required, and all of that has to be looked at together before we actually start installation on site. We have to maintain the system. Typically, it's maintenance free, but definitely with the building maintenance unit and let's say misuse of facade on the building has to be taken care of immediately for it to have a longer life. Obviously, if there is some design flaw in terms of how the wind load calculations are done, then you are in for a problem that cannot be solved easily and will have a perennial problem. So it's very important to have the right partner and the right criteria before you even start a project. Just quickly on the installation, this is how the unitized panels are installed, which we spoke earlier also. It can be hoisted. They're hoisted from top of the building, and you have minimal amount of laborers picking it up and putting it into place. There are a huge amount of softwares used, but the typical ones I have listed down just for everyone's knowledge. AutoCAD and Revit are the most important software used in this industry. Then there are 3D softwares like Rhino, HiCAD, Inventor, Grasshopper, and stuff like that, which are top of the line softwares, 3D softwares. For structural calculation, you have STAD Pro, which is the most commonly used software in terms of the structural adequacy. Then there are finite element softwares for thermal and stuff like that in terms of Therm, Visual and stuff like that used to eQuest, used to design the thermal or the energy performance of the system. I think that's it from my end.
So thank you, Mr. Eshan, for an insightful presentation that gave us a comprehensive understanding of facade systems. You've expertly guided us through the intricacies of complex facades, essential design factors, different types of facade systems, and critical performance elements like thermal, acoustic, fire safety, installation methods, and also the softwares that can be used in facade design. So we truly appreciate the depth and the clarity you brought to each of these topics. And we've learned so much from this presentation, but I would like to take a minute to ask you a few questions about the facades even further.
Absolutely, sure.
So I know you brushed upon these topics of maintenance, lifespan, and all of that to further the understanding. What are the maintenance requirements and expected lifespan of the materials used along with in the glass facade, and how do they impact in long-term costing?
So typically, as I mentioned earlier, they are designed to be fairly maintenance free, but there is a certain amount of basic preventive maintenance that needs to be done. The materials that we use, aluminum and glass as major, have a huge lifespan. So we design the building for keeping in mind minimum 50 years as a lifespan. Um, there is certain warranties given back to back on all materials in terms of glass, in terms of aluminum, in terms of the structural coatings application, in terms of the IGU manufacturing, which we pass on back to the clients. What we encourage is a larger education on site with regards to the end consumer on how the facade is to be treated, because it is in lieu typically of brick walls. You have a facade system. They are meant to be a structural barrier as well as a water and air barrier, but there are huge chances of abuse on site by the end consumer onto the system, which we have seen in our experience. So when that system is abused in terms of let's say marbles put onto the system, for example, or people screw in for their curtains, or wet areas are changed and there is water penetration from one floor to the bottom floor. So these are systems which need a higher level of education from the end consumer standpoint to prevent the abuse and in turn reduce the maintenance needed on these systems. So I think that is one area of thrust and care that has to be taken. Otherwise, once it is done and manufactured correctly and installed on site, apart from regular cleaning and preventive maintenance, these systems are typically maintenance free.
Right. Understood. So we'll end with one question that I'm also curious to know. So if you'd pick one feature to enhance a curtain wall system, what would it be and why?
So I think maybe down the line, because the maximum surface area is on the vision glass or the glass or the exterior, what you typically would like to do or what you would see eventually, and this is catching up really quickly, is incorporation of solar panels or what we call as BIPV, which is building integrated photovoltaics. So how do you maximum the use of this glass, which is facing on the exterior of the building, to generate energy from it and have self-sustainable buildings? I think the future will be to have an advancement in that technology as we go on to a carbon neutral kind of an achievement that has been committed by the country by 2050, and the whole world is talking about it. As you see more and more global warming affecting people, is to maximize this space or maximize this surface area to make it not only aesthetic and functional, but to also derive some sort of sustainability from the facade itself to reduce the carbon footprint of the material. So I think a major thrust on the BIPVs or the solar panels on as a glass usage is an area which is definitely being explored on. But with the right amount of thrust, I think in the next 5, 10, 15 years, we would see increased usage of this technology. I think that is definitely one of the active areas that we are exploring. And the other one I feel is use of sustainable materials into our construction. What initially we used to pride ourselves to saying that we are using zero recycled material or virgin aluminum or virgin glass. I think there is a higher acceptance and a higher knowledge to use recycled material into our construction. And I think this domain has to be actively explored and done in the next 10-15 years, so that we start giving back to the environment and stop taking from the environment continuously. I think these two things, in terms of sustainability and recycling, is where this industry is headed towards. This is my view.
Absolutely. That's great. So this brings us to the end of the webinar today.
Yeah.
And as we move forward in designing tomorrow's architectural landmarks, if I may say, today's insights on facade systems and glazing will undoubtedly shape safer, like you said, sustainable and visually inspiring structures.
Yeah.
So on behalf of Glass Academy and Ethos Empowers, we extend our heartfelt thanks to you, Mr. Eshan, for your time and guiding us through this fascinating world of facade systems. So thank you very much once again.
Sure, Anvita, it was a pleasure to do this. Thank you so much.